Good morning, CP Pre-Calc. Now what we're doing today, guys, is we're doing the last day of solving trig equations, and there's one more method that I'm going to teach you today, and it'll be the last method prior to our assessment. So we're going to learn this method today. On Monday and Tuesday, we're going to be reviewing, and you can work on your quiz next Wednesday and Thursday prior to spring break. All right, guys? Now what we have here is an equation, tan theta plus the square root of 3 equals secant theta. And we do not like, anytime you have a function like this, I do not like when I have a tan theta and a secant theta. I would like to have it have the same exact trig function. And the reason I also don't like it is because if I move the secant to the left, I would have three separate terms that the only greatest common factor that I would have would be 1. So I couldn't factor out a trig function to make my life easier either. So I need to figure out another strategy to solve this type of problem. Now when we go to our identities that we're all familiar with, we do see a relationship right here. Right here we see a relationship between tan and secant. However, both tan and secant are squared. So in this relationship, both tan and secant are squared. So what I'm going to do is I'm going to think, how can I somehow use this relationship? Because these are not squared. Well, what I'm going to do is I'm going to square both sides. So I'm going to take my original, and I am going to square both sides. Now the key thing here is when you're working with the left, it is a binomial. So you have to square the binomial, meaning when I square this, I have to rewrite this as tan theta plus root 3 times tan theta plus root 3. And that would be equivalent to secant squared theta. So I squared both sides, so I still have my tan and my secant, but I'm working with a secant squared now. So by having a secant squared, and we're going to eventually have a tan squared, I might be able to use my Pythagorean identity to help me solve this problem. So now what I'm going to do, guys, what I'm going to do here is I'm going to distribute the left. You guys like to use the word FOIL, either way. I get tan theta squared plus root 3 tan theta plus root 3 tan theta plus root 3 times root 3 is just a positive 3 would be equivalent to secant squared theta. Now by doing that, I have two like terms in the middle. And I can simplify them. And I can bring those common terms together. And I can write tangent squared theta plus root 3 would be 2 root 3 tangent theta plus 3. Now, when I look at this, my entire left side has two tangent terms, but my right side only has a secant squared term. So by looking at this problem, it's easier for me to substitute something in for secant squared because it's the only term with a secant. And now I know, because I squared it, I can come over here and go to my trig identities, and I'm aware secant squared theta is equivalent to 1 plus tangent theta. So what I'm going to do is plug that in as 1 plus tangent squared theta. Now by doing that, I have a quadratic, but I notice if I subtract that tangent squared theta from both sides, it's going to be eliminated. So it's going to be eliminated on both sides. And I'm just left with one tan term. So here I have 2 radical 3 tan theta plus 3 equals 1. So now I'm going to isolate my trig function because I only have one of them. I'm going to subtract the 3. And then I'm going to divide by 2 root 3. I'm going to simplify that, guys. And I do not have to rationalize it, but I can cancel out. It's 2 over 2. I can cancel them out. When I cancel them out, I'm left with a negative 1 in the numerator and a root 3 in the denominator. Now, what I want us to remember is when we talk about tan, guys, tan theta is equivalent to y over x. Now, if I look at my unit circle, so I have my unit circle, I'm bringing it over, I'm looking at my unit circle, I'm thinking of y over x. In this case, tan is negative. If tan is negative, I'm looking at quadrants 2 and 4, because that is when my tan value is negative in 2 and 4. So if I take a look at that, I don't see a 1 and a root 3. I see a lot of 1/2 and root 3s over 2. So I can take this and I can divide the numerator and the denominator by 2. And the reason that works out, because if I do the same thing to the top as the bottom, it's just like multiplying by 1. Now I'm able to see that I have to have this and the negative can go either way. Only one of them could be negative. This is a y and this is an x. Now I know I'm looking in quadrant 2 and 4, because in quadrant 2 and 4, tan is negative. So if I look in 2, I see a 1/2 for my y here and a negative root 3 over 2, which makes sense. A positive 1/2 over a negative root 3 over 2 will result in a negative 1 over root 3. So that theta value is 5 pi over 6 in quadrant 2. Now I'm thinking the same thing. I want y to be a 1/2. I go to quadrant 4. Y is negative 1/2 at 11 pi over 6. Negative 1/2 over a positive root 3 over 2 results in being simplified to a negative 1 over root 3. So that's an 11 pi over 6. So I had 2 answers on my unit circle between 0 and 2 pi. However, because we squared it, we squared both sides up here, we might end up with what we call an extraneous solution. If you square both sides of your equation, you can end up with an extraneous solution, meaning it's a solution that you get when you solve the problem, but it does not work in the original. And when I mean original, I mean the absolute original, the original problem that you were given. So in a problem where you square both sides, you must check your solutions. All right, so I have to check both solutions. I have to check theta equals 5 pi over 6, and I have to check theta equals 11 pi over 6. So now let's put it in the original. This is tangent of 5 pi over 6, right, plus root 3 equals the secant of 5 pi over 6. And guys, I'm going to let you just use your calculator for this. If you put this, make sure if you utilize your calculator that if we're working with radians, go to your mode, and you want to make sure that it's in radians. All right, guys? So once I know it's in radians, I'm going to say tangent of 5 pi divided by 6 plus root 3. So this side is 1.155. Now let's try secant. I don't have a secant on here, but secant is equivalent to 1 over cosine. So you can put 1 divided by cosine of 5 pi over 6. Use that knowledge. Okay? So if the secant is 1 over cosine, so when I put that in, I get a negative 1.155. These two are not equal. Therefore, 5 pi over 6 cannot be a solution. All right, that's an extraneous. So we already know 5 pi over 6 is an extraneous solution. Okay, so this is an extraneous solution. Okay, now let's check our 11 pi over 6. I have tangent of 11 pi over 6 plus root 3 equals the secant of 11 pi over 6. Now again, I'm letting you utilize your calculator for the checking part. So if I take a look, I'm doing tan 11 second pi divided by 6 plus root 3. That side I'm getting 1.155 approximately. Now secant, I don't have a secant button, but I can put 1 divided by cosine 11 pi divided by 6. And I get 1.155 approximately. They both are equal, so that checks. So my only solution for theta would be 11 pi over 6. All right. That would be it. That would be my solution. All right, so the only thing is that when adding that step of squaring both sides, you have to make sure that you check your answer. All right, guys, let's try one more problem. All right, guys, the next problem we're going to do, I just want to make sure that I write it down correctly, is cosine of theta plus 1 equals sine of theta. And we're going to use that same method. We are going to square both sides. And the reason I'm going to do that is I see a cosine and a sine, and I think of all my identities on my blue sheet, and I cannot use one of them to rewrite cosine as sine or sine as cosine. I look at the double angle identities I gave you yesterday. I don't have a double angle. I don't have a 2 theta anywhere. So since I don't have a 2 theta anywhere, I cannot use those. So what I'm going to do is I'm going to use that concept. We're going to square both sides. So we're going to square cosine theta plus 1 squared equals sine theta squared. Now let's rewrite this. This is a binomial. That's cosine theta plus 1 times cosine theta plus 1. And that will equal sine squared theta. So now let's distribute this, guys. We get cosine squared theta plus cosine theta, foiling, plus a cosine theta plus 1 would equal sine squared theta. Now, the whole left is in terms of cosine, and I have 2 common cosine terms. And that's going to simplify to cosine squared theta plus 2 cosine theta plus 1. Now, since I have 2 cosine terms here, the easiest thing to do would be to substitute something in for sine squared. So if I go over here and I want to substitute something in for that sine squared, I'm going to look here and I'm going to identify that sine squared is equivalent to 1 minus cosine squared. So that is going to go in there, 1 minus cosine squared theta. Now, when I do, what I'm going to do is bring everything to the left. Bring everything to the left, guys. So I'm going to add that cosine squared. And I'm going to subtract that 1. Now, this cancels here, and this cancels. 1 minus 1, that cancels too. So you're left with cosine squared plus cosine squared is 2 cosine squared theta plus 2 cosine theta equals 0. Because everything here just canceled. So when I take a look at that, now I can say, actually, I can factor out a GCF. I have that cosine theta and cosine theta. Let's factor out that cosine theta. If I factor out the cosine theta, I get 2 cosine theta plus 2. Oh, actually, I can factor out the 2 too. So if I factor out that 2 cosine theta, I'm going to get cosine theta plus 1 in parentheses. Now set both terms equivalent to 0. So 2 cosine theta equals 0 and cosine theta plus 1 equals 0. Here, my cosine theta would have to be 0. Here, my cosine theta would have to be negative 1. So back to that unit circle. Let's take a look. I go to my unit circle. Cosine is x, so I look when x is 0 and I look when x is negative 1. Well, x is 0 at pi over 2. X is also 0 at 3 pi over 2. Here, negative 1. X is negative 1 at pi. All right, now we said we have to check everything, so let's check everything. All right, so let's start. Now, when you check, again, I want to emphasize you must go back to the original. We must go back to the original, and we check when we square both sides. Anytime we squared both sides, we have to check. So, if I go to this check, I'm checking all 3 thetas that I earned, I solve for. So I have theta, I have to check pi over 2. I have to check 3 pi over 2. And I have to check pi. So let's take a look, guys. Let's check everything. Now, if I put them in the original, and again, I'm going to let you utilize your calculator here. You have cosine of pi over 2. This one, actually, I probably don't have to. Plus 1 equals sine of pi over 2. Well, guys, take a look at this one. This one I actually don't even have to. Sorry. There you go. I don't have to. I can just use this. Cosine of pi over 2 is x. X is 0. So 0 plus 1 equals sine of pi over 2 is 1. That checks. That's a solution. Now I go here. I go cosine of 3 pi over 2 plus 1 equals sine of 3 pi over 2. Check it. Cosine of 3 pi over 2 is 0. 0 plus 1 equals. Sine of 3 pi over 2 is negative 1. They are not equal. That does not check. Now let's try pi. Cosine of pi plus 1 equals sine of pi. So cosine of pi, look here, is x is -1. Plus 1 equals sine of pi is 0. -1 plus 1 is 0. That checks. So I have 2 that checked. So that means my solution set for them, theta would be, that solution set would be pi over 2 and pi. And that would be my solution. All right, guys, you have 2 problems today for your assignment, and that's it. I want you to have a wonderful weekend. If you have any questions, please come to my office hours. I will be on Google Meet. I send out the link through an announcement. If you have any questions, please come visit. In addition, I want you to have a great weekend. Get outside on some nice walks and stay safe. All right, guys? I hope all is well. Bye.